last year's conference, you might remember Orisi. I was one of my colleagues, so he presented on the stakeholder engagement and the surveys that we did in some of the countries around the Pacific. So today I'll be presenting on the data that we have collected and the modeling work that we have done to calculate some replacement cost of the infrastructures in some of the countries around the Pacific. So, sorry. So this is just the outline of my presentation. So I'll be briefly talk about the project overview, just to give a brief background on the project itself and the approach that we took to do the modeling and some examples of the products that we developed and some of the challenges that we faced. Like one of our presenters presented earlier, that in the Pacific, we still have a long way to go in terms of the data that we have to help inform decision makings. So just a brief background on the project, PCRAFI project. So it's a program that is funded under the World Bank. So there are a few donors that contribute towards the project, especially Germany, United States, Japan, Canada, and the United Kingdom. So it's a 3-year project. It was supposed to be implemented in 2019 to 2021, but due to COVID, the project was not implemented until 2022. So in 2022, the time frame was really short, so they expected us to complete this project within 10 months. So we didn't do a lot, but yeah, that's the implementation period. But then this is like a continual improvement from the PCRAFI I project. So the main objective is to improve and update the Pacific risk information system, and at the same time strengthening the Pacific Island countries for disaster risk and management and financing. So the main outcome that we are trying to emphasize through this project is to build capacity buildings throughout the Pacific Island countries. So these capacity buildings is to ensure that they collect their own data to make informed decisions. And the second outcome is for the countries to use the data that collected for planning and decision making, risk assessment, management, financing, and to inform product development process in their own countries. So the project was initially aimed to cover the 14 Pacific Island countries, but as I mentioned, due to COVID, we only covered 5 countries. So some of the activities that we covered within the 10 months period, we did some stakeholder engagement. Then we go out and do some trainings to train the government staff within those countries to how to collect the data. And then we have the exposure data survey or data collections. And then we went back again to train them how to use the data that they have collected. And from that, we did some consultation and verification, especially for the modeling part of the work. So these are some of the information that our team collected, not our team, but we include the staffs within the respective ministries around in the 5 countries. So we collected information on building, roads, ports, airports, power, and other infrastructures and utilities. So this is just a brief summary of what the whole project that we did. So the first thing we did is we identify areas of interest, and that was mainly influenced by the focal ministries in those countries. And then we did some desktop reviews, and that's where we engaged Lannis teams to come in and do some digitizations of the buildings, footprints around in the Pacific. And then we go back again, do the data collection trainings. After that, we did the data collections, validations, and data cleaning. And then from the data that we collected, we uploaded into PCRIS, or now it's being migrated to Nexus. And then we go back again to those countries and train them how to use the data. So, and then we have the exposure modeling component, where we try to model those data to do some calculations on the replacement cost of the infrastructures in those 5 countries. And then we have the dissemination of the output. So the last step is still incomplete. We are thinking of doing the dissemination workshop early next year. So yeah, these are some of the open source tools that we use, because we all know that in the Pacific, we can't afford to buy those licenses for some of the software. So in order to buy, like when the project ends, there is sustainability of the project. So that is why we emphasize on open source tools, where they can be able to continue the work that we've done after the project ends. So we use Kobo Toolbox for data collections, and then we have the QField, OSM, QGIS, and Python for programming, and we have the Nexus where we store the data. And yeah, like I've said earlier in the Pacific, yeah, there are lots of challenges, and the two main challenges that the Pacific Island countries face is the climate change. There are lots of islands that are sinking now and affected by climate change, and also we have the natural disasters. Just last year I was in Vanuatu and there were 2 cyclones happening one after the other. Cyclone Judy and Kevin. So yeah, and the thing that is missing is the data available that could help the decision makers to make informed decisions. So from this work that we're doing, we're hoping that they can use those data to inform decision making areas, and they can be able to like identify areas, which areas that are high risk to certain disasters. And they can use the information for other planning as well, and also for disaster risk financing. That's currently the hot topic in the Pacific, so talking about that. And also we can use this information for rapid exposure forecasting and planning. So when there is a tropical cyclone, they can be able to estimate out the number of buildings that will be affected, or the infrastructures, and also the population that will be affected, and so forth. And also the post-disaster needs assessment. Most of the time after a natural disaster happened, for example, tropical cyclone, we often go out and just collect information. Most of the time we're just guessing, we're just estimating that this amount of damage cost this amount. But actually we don't have any information to back up our figures that we come up with. So from this modeling work, we can be able to back up our facts, because most of the time we just overestimate, or sometimes we underestimate. So the approach that we took, we try to make it simpler so that after the project ends, the Pacific Island countries can continue the work that we did. So we use regression analysis and scaling. So there is a reason why we do scaling, because of the data that we collected, and also we decided on the layers that will be modeled and the attributes that will be used for calculating the unit cost of construction. And the calculations were done in USD. And the other thing is we consult with the member countries. So that is the important part, because they are the ones that will be using the data, and we need their input. Otherwise, if we go on and just do up the model and then send it back to them, it will be no use to them. They will say, oh, we weren't consulted, and our work will be wasted. So that is why we have consultations with those country counterparts. And this work was also done in consultation with the World Bank team that were managing the project. So these are the data that we collected out in the field. So we decided that we will use all the data we collected, and for the buildings, we categorized them into 2 categories, the residential and the non-residential. And the attributes that the countries agreed upon, and within the SPC team as well, for the buildings, we decided that the walls, roof, foundation, building heights, those are the main attributes that we'll be using to calculate the unit cost of construction, or the replacement cost of that particular building. And the others, roads, ports, they're all on the table. And now the building classifiers. So with the buildings, there are it's a bit tricky, because in developed countries, most of the buildings, they have the same materials for the walls and all that. But in the Pacific Island countries, it's a bit different, because a house can have the different walls can have different types of material. One side of the material will be metal sheet, and the other side will be just cardboard. So it's a bit difficult for us to do some to classify those buildings together. So what we did is we did up an analysis, and we find out that the total combination of classification that we have based on the surveys that we done, it was up to 50. So what we did is based on those building classifications, we reduced it down to 18. So it's on the left table, you can see that. And then we do some code classifiers, so it's easy for us to do up a coding to code all these processes that we have in order to calculate the replacement cost. And also the other factors that we consider is the location of the building, whether the building is in a urban area, peri-urban, or rural area. So the diagram here just summarizes the process that we have. So first we did the data collection, we standardized the data, and then we classify them into the building types, different types of buildings. And then we consider the topology, whether it's either urban, peri-urban, or rural. And then we did some weighting based on the type of material and the locations of the buildings. And then we do the calculations. So the validation part comes in when we have consultation with the countries. For example, in Vanuatu, we have a consultation with the Association of Engineers. So we just go through the process and to ensure that they agree with what we have done, and based on the unit cost of construction within those countries. So because the cost that we get to calculate this replacement cost is the actual cost in Vanuatu. I mean, for example, Vanuatu or Samoa or Tonga. So if they agree with the process and we go through some calculations and it's in line with their expected range, then we go ahead with it. If not, then we have to redo again. So yeah, on the right, that's sample calculations of what we done. So what basically does is the code runs through and pick up the values based on the building locations, whether it's rural, urban, peri-urban, and then the type of materials, and then it adds up all, and then it give out the final result. So the final output that we have was in the admin, was aggregated to admin boundaries. And that's because of the data that we have. It mainly depends on the coverage of the data. I mean, the geographical coverage. So for the infrastructure, it's a bit straightforward. So what we did is collect the data, then we do the valuation. So, for example, those layers that we have a geographical coverage of the whole island. For example, in Tonga, we have the roads coverage of all of Tonga. Then we didn't do any scaling, but for those layers that we have like half data or some incomplete data, that's where we did the scaling. So that's the example of just the calculations that we have done. And yeah, this is one of the output for Solomon Islands. So it's the map showing the residential building in Solomon Islands, which areas that have more building and more like the costings are high. So that's it. And yeah, this is some of the outputs. Just an example here, the admin 1 level, that's a provincial level. And yep, so like I mentioned earlier, the report hasn't been disseminated yet. So we are hoping that next year World Bank will bring together the countries that were part of the PCRAFI project, including PCRIC, it's the Pacific Catastrophe Risk Company, yeah, PCRIC. So these are the company in the Pacific which ends out, it gives premium insurance to Pacific Island countries in terms of disaster risk. So like countries can buy some premiums there, and if a disaster happens, then they can assist. And also we have distributed the data to the Pacific Island countries, the countries that were part of the project. And there are other organizations that are currently using the data that we have collected. For example, we are using it in the current project that I am with now, partner, and then there's the other data, the FOSS project, the UN, and some other projects in the Pacific. So this is just an example of how we use the data that we collected from PCRAFI. So, sorry, excuse. So with partner, what we do is we use those exposure data that we collected and the other data, we run it through Riskscape, and then we do some calculations there to give up the products, like, for example, sea level rise, which areas are impacted, or weather cyclones and all that. So this is just an example, one of the outputs that we are hoping to get. This is a test case for TC Lola, Tropical Cyclone Lola. So we can like give a rough estimate of how many buildings are affected, the people or the infrastructure like roads, schools, health centers, etc. Yeah. And for sea level rise, so we done some scenarios within like 10-year period, 20-year period, 50, 100, and 150 years period. So it can basically like gives you the projected annual average loss for the infrastructures and all that. And yep, some of the challenges that we face, there are so many challenges, but the two main ones that stood out is the time frame. So we were like given 10 months to collect the data and then to do the modeling and all that. So, and the other factor is the incomplete data. So some of the data we are unable to completely collect the whole data for the whole country. So that's some of the factors that we face, and that's why for those layers we consider the scaling up those layers. And the way forward, we are hoping that in the future, now the model that we did is based on the admin boundaries, but in the future we'll try to do the calculations based on grids. Like in the Pacific, most of the populations are along the coastlines. So in the future, we're thinking of doing up 100 by 100 grids along the first kilometer from the sea, and within that we can do 1 kilometer by 1 kilometer. So yep, and we're expecting that the countries will continue the work that we've done on PCRAFI. And yep, that's it. Thank you.
Okay, many thanks, Thompson, for keeping to time as well. We have time for maybe 1 to 2 questions. Are there any questions from around the room? Yes, I will come to you.
Hi, thanks a lot for the presentation. A question on you mentioned missing data was one of the key challenges of the project. Can you be a bit specific? What were the data layers that were needed the most and where you didn't have the data? Was it buildings, was it roads, was it roof? Can you be a bit more specific? Were the data layers that stood out that were missing?
We have the layers, but the attributes, especially the buildings. We may have the building footprints, but then there's no information about the type of materials and all that, yeah. But for some infrastructure like roads, we have all those information, except buildings and other, especially buildings.
We have another question.
Hi, that was a great presentation. Just a small, quick question. While you were doing any evaluations, did you take into account any present asset data conditions as well, or present asset conditions as well? If it's good, it's bad, it's poor. So in terms of roads, bridges, airports, and different stuff like that. Because that was a very comprehensive pattern which you followed up. That was pretty good.
Thank you. So yes, from the template that we created, there's a condition as well. So the calculations were based on the current status of the building. So yes, we consider the conditions as well.
I would give you the question, but we're just really running out of time. But I'll bring you Thompson to your afternoon tea. So can everyone give another round of applause for Thompson?